Hi, I'm Terry Butchie from Ohio State University's Math Literacy Initiative. We're doing these Monday math days to help out with caregivers and parents and guardians at home who are working with your students now that we're not going back to school for the year. So please let me know if you have questions about other concepts that you'd like to have some ideas about activities for, or just want to better understand. Let me know and we'll make sure we address your concerns. So today at 1 o'clock, our 1 o'clock session, we're doing graphing quadratics using the vertex form. This is one of the primary functions of being able to deal with graphing and understand why we even want to graph things. That's really the question. Why do you want to graph stuff? So we'll talk a little bit about why you would even want to graph and what that means. And then today at 2 o'clock, we'll be doing multiplying fractions, which is a 5th grade standard. So let's look first at the form that someone was asking about, which was the vertex form. So this is an equation of a line. Sorry, not a line. This is actually a parabola. And we know it's going to be a parabola because this is called the degree right here. This is called the degree of the equation. So the degree of the equation is we have just an x and we have an x squared. So that means this is going to look like a parabola. That means it's going to look like a U, like this, or it could go down like this. But we know that the general shape, it could be super narrow like this, steep, or it could be really wide also, so it could look like this. So all sorts of smiles or frowns. So we want to think about them in terms of this motion that the parabolic curves go by. And there's a lot of things that we can do to figure out what a curve's going to look like. And what the curve looks like gives us information about whatever the equation is responding to. So we don't just I know when you were in Algebra 1 or Algebra 2 or whatever, you learned all these formulas and learned how to graph and all that kind of stuff. That's not really the interesting part. I mean, graphing's interesting, but it's really what you can tell. What do you determine because of the graph? So what kind of decisions can you make because of the graph? This is a representation of something. What information does it give us? So this is the general form of a quadratic equation in vertex form. So vertex, if we talk about the vertex, let's just look at our parabolas over here. The vertex, if I marked them all for you, so here's the vertex. That's the vertex. That's defined by what happens on every one of these curves at the vertex. What happens? So we're going along the line, vertex, and then what happens? It starts going back up. So here we go. Vertex. What happens? It starts changing directions and going down. So what we know is at the point of the vertex, that's where the parabola changes direction. So it's going down, then vertex. That means it has to change direction, go up. Go down, vertex, change direction, go up. And what we know is really cool about these is that all of these it's called symmetrical. That means that these distances, if we have this line, this is called a line of symmetry right here, we know that these distances are the same measure. That means that it's symmetrical. They have equal perpendicular distances from the line of symmetry. That's what it's called. That just means when you have a right angle here, this distance here will be the same as this distance here. All right, so that's another really interesting thing about parabolas that we can use to make decisions when we're graphing a parabola. So now let's talk first about what is the vertex. So if you see an equation or an equation of a parabola, a quadratic equation that looks like this, and it's in this form, this is called the vertex form. And what that means is if we have this equation, we can figure out what this pivotal turning point is. So what is that point where that curve is going to change direction? That's really what the vertex is. And it's an important point usually because, again, all these equations represent something. So it's really, these equations are about data. What can this data tell us? What's going to be happening when this curve hits its vertex? What is this telling us? What's going to happen as it keeps going? So those are the important questions. Now the vertex form of an equation of a quadratic looks like this, and we can pull the vertex, this exact point on a graph, we can pull that out with the h and the k. So what that, remember, our system, we have x and y coordinates. So if we want to graph something that has this information, that tells us the x coordinate and the y coordinate for the vertex. So let's say we have an equation of a line that looked like this. Y equals 3x minus 2 squared plus 7. All right, so if we had that equation of a line, first of all, that equation of a line represents something. That's important. But then, because it's in vertex form, we can just pull out this point. And again, remember, vertex is the place where it changes direction. So we can pull that point out because it's already in that form. So when you're given the vertex form, this is probably the easiest way to graph a parabola. So let's look at what's important. So we know that this h is important. And remember, this is a minus here and this is a minus here. So that means that's just a straight up 2 for your h. So 2. And then here we have a plus k, and here we have a plus k, and k in this case is 7. So we know that 2, 7 is going to be this point when we graph our line. So we can get that 2, 7 point on, and then we can start graphing it. Now let me show you why that 2, 7 is important. Now I'm going to, so this is again how you find the vertex. Now we're going to do one where we actually use the vertex and a coordinate plane to graph it. We're going to do 3 of them. So let's look at these first. All right, so let's look at our vertices, vertex, that's plural of vertex. So we have our, remember, I'm going to write this down at our bottom just so we can remember. Y equals a times the quantity x minus h squared plus k. All right, remember that's our formula. This is our formula here. So we have, here's our h, here's our k. So let's just write down the vertex first. Here's our h, here's our k. All right, so we got that vertex all written down. Now, let's graph it. So, what are we going to need to know? I'm going to put my coordinate plane here. So this is the x-axis, remember, and this is the y-axis. So when we have a coordinate point like this, it's in the form of x, y. So that means we're going to go left or right first, and then up or down, depending on x and y. You can do a dance motion. So x is 4. 1, 2, 3, 4. So that's how far it goes over on the x. Y is 3. 1, 2, 3. So I'm going to put my point, go over 4 and up 3. I'm going to put that point right there, and I'm going to mark it 4, 3. So we know, because of our other parabolas that we just kind of drew, that that point, that vertex, is going to be the point of the change in direction. So we know that the parabola is going to go either open up like this, or it's going to open down like this. It'll open either up or down. And remember, we talked about that it could be real tight to the axis, or it could be real wide to the axis. So the best way to graph from here is to remember what we said about the fact that parabolas are symmetrical. That's an important key piece. Because they're symmetrical, it makes it much easier to graph them. So we know that whether this parabola goes up or down, it's going to hit this y-axis somewhere. This is the y-axis right here. It's going to hit this y-axis somewhere. And what do we know about every point that hits the y-axis. Let's just think about some points that might be there. So we know that this point right here is called the origin, and the origin is a point 0, 0. We know that this point can be named 0, 1, because we didn't go over it all, we just went up. We know this point is 0, 2. We know this point is 0, 3. So what do we know about all the points on this y-axis? What is true about all the ones that I just put? Well, x is equal to 0. On anywhere on this line, x is going to be equal to 0. So if we know that, we can use that to figure out what another point might be. So I'm going to go ahead and recognize that if x is 0, that's going to tell us where, if we plug that 0 in for x, that'll tell us what y value we have that crosses this axis. So let's just do a little bit of computation now. So we have y is equal to 2 times x. Oops, we're going to put a 0 there in for x. Substitute a 0 in for x. Minus 4 squared plus 3. So what do we know? Y is equal to 2 times 0 minus 4 is negative 4. But remember, we're going to square that. Plus 3. Now we have 2. Negative 4 squared is 16. Because a negative times a negative is a positive, we'll do that another time, plus 3. So 2 times 16 is 32. 32 plus 3 is 35. Holy moly, that's a big number. So what do we know? We know that the point 0, 35 is going to be on this graph. That's going to be way up here. So 0, 35. So I'm just going to put it right here. It's not to scale, but it's okay because we're just looking for the points right now. So we have the point 0 and 35. So I know now that it's going to open up. Because if it has to go from here to here, that's the only way this curve can go is up. Now we use our understanding of the symmetry of parabolas. And so if we think about this symmetry, we could actually take this and fold it over on itself right on that vertex, and that those lines should match up. That's a good test to see if you've drawn it correctly. But let's look here. So I'm going to look at this line of symmetry. That means that's the line we would fold it on to kind of match over. And remember what I said. If two things are symmetrical, we know that their perpendicular distances will be the same. So we know that whatever this is going to be the same thing, right? That'll be the same thing. So how many points over did this go? So we're at 4 right here, and so we're on 4. This is 4, 3 right here. So that means this distance here, see this distance here, that's going to be the same as this distance here because these lines are parallel. So what is this distance? Well, we went over 4. That means here, that's got to be a 4. So this distance here is 4. That means this distance also has to be 4. And because of that, we can tell what this point is going to be. Well, we already know the y because it just went straight over. So we already know the y is 35. But now we have to figure out the x. So if we went 4 to get here and then 4 to get here, we have an 8 there. So that's just a quick sketch of how you can do that. I'm going to do 2 more fairly quickly, and then we're going to talk just a little bit about the application. So there are all kinds of variations of this also. So let's talk first about this first one here. So remember we have this y equals a times the quantity x minus h squared plus k. So remember the h and the k, those are the vertices. Or vertex, excuse me. So it's in the form x minus h. So let's look at this one because it doesn't say x minus 3. It says x plus 3. But what that really, so that's the same as x minus a negative 3. Because minus a negative, now we'll do all the operations with integers on another one, or so you can take a look. But that's what this becomes. So now our vertex in this one is a little bit different. So because it's not in the form x minus, so we're going to have to put it in that form. That means the x coordinate of the vertex is going to be a -3. So we have a -3 there, and then we have our k is out here, so that's 5. So let's go ahead and graph this. All right, so we have 1, 2, 3 negatives, 1, 2, 3, 4, 5 positives. So here's our vertex, -3, 5. What happens at the vertex? It changes direction. So if it's going to open up, then it changes from going down to going back up. If it opens down, it changes from going up to back down. So, and right now, we don't even need to know which way it opens, because we're going to find out where it's going to hit the y-axis. That's the important piece for this. So where does it hit the y-axis? Now remember, when we were doing it over here, we know that at every point on this y-axis, the x value is 0. So I'm just going to plug an x value of 0 in for this. So we have y is equal to, I'm going back to the original equation, is equal to the quantity 0 plus 3, because I'm going to plug that 0 of x in, squared plus 5. So y is equal to 0 plus 3 is 3. 3 squared plus 5. So that's y is equal to 3 squared is 9. 9 plus 5 is 14. So what does that tell us? That tells us when x is 0, so when x is 0, y is going to be 14. So when x is 0, y is 14. Let's figure out what that goes. So 0, well, we go up here to get your 5, but now we want 14. So I'm going to take a stab at it, be about right here. Now, what is the coordinate point there? We know it's on the y-axis, so we know it's a 0 for x, because at every point, we just showed it over here, every point on the y-axis is 0 for an x. So we have 0 and then 14. So we know that this is where it changes direction. So if it has to go through this point up here, it's going to open up. It's going to open up there. And remember, it's symmetrical. That means it's going to open up like this. So we're going to use our understanding of parabolas to figure out that if this is that line of symmetry, that means we could fold these things over. If that's that line of symmetry, then that means this distance here, it doesn't look the same, but these are going to be the same. All right. So what do we know? What's the distance here? The distance from here to here, this right here, is going to be the same as the distance here from here, because these two lines are parallel. So we know that two lines are parallel whenever their perpendicular distances are congruent. That just means they're the same. So we know that we went over 3. Now look, we went to the left, which means -3. But the negative just tells us our direction, that we're going on the x-axis. So the value of this space is 3. If the value of this space is 3, then that means the value of this space has to be 3 also. So now let's look at this. So if we know that this point is going to have, we know what the y is going to be already. The y is going to be 14. We just have to figure out what the x coordinate will be. Well, what do we get? We go 3 this way, and then another 3. So we know we're moving 6 away from this axis. And in what direction? So that's a -6, because we're on this side of the x, or of the origin. Okay? So this is how you can plot any graph using the vertex form. Let's talk a little bit about a practical application of this. I just want to tell you why it's important to be able to know how to do something like this. So, right now, our country, well, the world is focused on this pandemic, and we know that that they've been talking about flattening the curve. So when they say flattening the curve, what does that mean? Let's think about it as a parabola. So if we think about the number of cases of COVID, it's going up and up and up right now, and it hasn't made the turn yet. But what do we know? We know that there's this It's going up and up and up. And then remember what a vertex is. It's when the parabola changes direction. So if it's going to keep going up, the vertex will be where it starts going back down. Okay? Now, again, this is real data. So these curves change the more data you get, the different it'll look. But the people nowadays that are talking to us about this particular virus, they're using mathematical modeling to find information. So we need people who can do things like that. And so that's why we want to make sure that we're really understanding how this curve works and what it means. So here's what we know. If this is the curve of the number of COVID cases, we know that once we hit that peak and start to flatten the curve, so now they are talking about flattening the curve, so it may go a little flatter and then start to come down. But if we're looking at it purely as a parabola, we know that if this is the vertex right here, what can we tell? Theoretically, whatever this distance is, theoretically, this will be the same. So this kind of information is good information to have just when you're watching the news or reading the paper or finding out about information that goes in any parabolic curve or the data that fits in a parabolic curve. So these are the important reasons why we need to do this. Yeah, we need to know how to graph an equation given certain parts, but that's not the important part. Once you graph it, then we need to be able to make some decisions about this. So if we know about how long it takes to peak, then we know about how long it's going to take to go back down, and that means we can make some decisions about when to open up, when we can start walking around again, all those kinds of things. That's all math. That is all mathematical modeling. So it's really important not only to understand how to do just the functional pieces, these primary pieces, but also to be able to use that data to make some decisions.